Pakicetus. This is where the story of whales truly begins, around 50 million years ago in what is now Pakistan. It looked nothing like a whale at all, more like a long-legged wolf with hooves, roughly the size of a modern coyote. It lived along rivers and lake shores, hunting fish in shallow water rather than swimming the open ocean. What makes it remarkable is the inner ear structure, which scientists use as the defining clue linking it to whales despite its dog-like appearance. Nothing about its body suggested the giants that would eventually descend from creatures like this, Ambulocetus. A few million years after Pakicetus, this animal took the next dramatic step toward life in water. Its name literally means walking whale, and it moved with the awkward power of a crocodile, dragging itself on land, but becoming far more graceful once submerged. It weighed somewhere close to 300 kilograms, about the size of a large male lion, yet it hunted more like an alligator, lurking near the surface before lunging at prey with crushing jaws. Its legs were still functional for walking, but its skeleton shows a body already leaning heavily toward an aquatic future. Kutchicetus. Around the same period, a much smaller relative was carving out a different niche entirely. It measured barely over a meter long, closer to the size of a large otter, and its body was already built for constant swimming rather than the awkward waddling of its larger cousins. Long jaws lined with narrow teeth suggest it specialized in catching slippery fish and crustaceans in coastal shallows. Its proportions hint that early whales were experimenting with several different body plans at once, not evolving along a single straight path. Maiacetus. Not long after Ambulocetus, this whale offered one of the most revealing fossils in the entire story of whale evolution. About the size of a large sea lion, it still had sturdy limbs capable of carrying its weight on land, likely resting on beaches the way seals do today. What made it extraordinary was a single fossilized female found with a fetus positioned head first inside her, the same orientation land mammals use for birth. That single detail told scientists these early whales still gave birth on land, not in the water, marking a clear line between this stage of evolution and everything that came after. Rodhocetus. By this point, evolution had pushed further into the water, and Rodhocetus shows just how quickly the transformation accelerated. Its hind limbs had shrunk dramatically, too small and poorly connected to the spine to support real walking on land. Instead, it likely moved the way otters do today, undulating its body to propel itself through water with surprising efficiency. It probably measured around 3 meters long, comparable to a large dolphin, and represents the moment when whales stopped needing land almost entirely. Georgiacetus. This whale pushed the transition one step further, and its hips tell the whole story. The connection between its pelvis and spine had essentially disappeared, meaning its hind limbs, if it still had any function in them at all, could no longer support real movement on land. At around 3.5 meters, similar in length to a small pickup truck, it likely spent its entire adult life at sea, only its ancestors ever having walked on solid ground. Fossils of this whale come from what was once the shallow coastline of ancient North America, showing just how widely this transformation was happening at the same time across different regions. Basilosaurus. If Rodhocetus hinted at what was coming, Basilosaurus made it terrifyingly real. Stretching close to 18 meters, longer than a city bus, it had an elongated serpent-like body that made early scientists mistake its fossils for a giant reptile, which is why its name mistakenly means king lizard. Despite the size, its brain and teeth suggest a genuinely dangerous ambush predator, capable of biting clean through the skulls of prey animals nearly its own length. Bite marks found on the remains of smaller whales show this creature likely hunted other whales as a normal part of its diet. Zygorhiza. Sharing the same seas as Basilosaurus, this whale shows that not every predator of the era needed extreme length to be effective. At around 6 meters, roughly the size of a large modern minke whale, its body was far more compact and proportioned, closer in shape to what people picture when they imagine a whale today. Its teeth were still sharp and clearly built for gripping fish and squid rather than filtering them, placing it firmly in that strange in-between world where whales hunted like predators but were beginning to look the part of gentle giants. Dorudon. Living alongside Basilosaurus and frequently falling victim to it, Dorudon offers a striking contrast in scale. It measured around 5 meters, closer to the size of a modern orca, with a body already resembling something recognizably whale-like rather than reptilian. Fossil evidence repeatedly shows Dorudon skeletons bearing tooth marks matching Basilosaurus jaws, painting a picture of a genuine predator-prey relationship within the same ancient seas. Its more compact, efficient swimming shape hints at the direction whales would eventually take, favoring speed and control over sheer length. Janjucetus. This one breaks almost every expectation people have about baleen whales. Despite belonging to the same broad group as modern giants like blue whales, Janjucetus had no baleen at all. Instead, it carried sharp, gripping teeth, suited for seizing fish and squid. It was small, likely no longer than a large dog, with unusually large eyes, suggesting it relied heavily on sharp vision to hunt. Its existence reveals that filter feeding, the very trait that defines baleen whales today, was a later evolutionary experiment rather than an original family trait. Aetiocetus. This whale captures evolution caught mid-transformation, almost like a snapshot of a species changing its entire way of eating. It still had teeth rooted firmly in its jaw, yet tiny grooves along the bone suggest blood vessels once feeding early baleen tissue growing in alongside them. Roughly the size of a large dolphin, it likely used both methods somewhat clumsily, snapping at individual prey while also beginning to experiment with straining small animals from the water. Few fossils in the whale record show this dual toolkit so clearly, teeth and baleen coexisting in the same mouth. Llanocetus. Long before blue whales ever existed, this creature proved that filter feeding could support serious size almost from the very beginning. Reaching lengths close to 8 meters, comparable to a loaded shipping container, it likely fed by gulping mouthfuls of small prey and pushing the water back out through early baleen-like structures. What makes it surprising is the timing. This level of size tied to filter feeding appeared far earlier than scientists once assumed, showing that gentle giants were possible almost as soon as the strategy itself emerged. Livyatan melvillei. Few prehistoric whales carry a reputation as intimidating as this one. Estimated at over 13 meters long, it possessed teeth up to 36 centimeters in length, among the largest functional teeth ever recorded in an animal, rivaling even the largest teeth known from predatory dinosaurs. Unlike modern sperm whales, which mostly hunt squid in the deep, Livyatan appears built for direct combat, likely preying on other whales and large marine animals near the surface. Its discovery suggested that the ancient oceans hosted a genuine rivalry at the top of the food chain, with this creature and giant sharks of the era potentially competing for the same enormous prey.